Okay, so we started section 13.2 in class. A vector is a directed line segment. Equivalent vectors have identical length and direction. Let's see, we found the component form of a vector. Remember that you always do the end minus the beginning. And you can have IJK form, which is like called standard form, and the with the little brackets, it's called a component form. Then we figure out how to do the magnitude of a vector. So if it's already in component form or IJK form, it's really easy. You just like square the parts and add them up. And then that was a 42 right there. All right, and then we got to here, and you guys did the magnitude of this vector already, and we did that one as an example. So let's just do basic vector operations. So basic vector operations are supposed to be like, multiplying, adding two vectors, and so forth. So like some basic things that you have, let's say you had a vector v, and it looked like that, right? And so that vector right there looks like this. Hang on, I'm trying to get this off of here. Oh my God. Oh. Okay. Okay, so you have that vector there. Let's say you want, and that's called vector v, right? So if you want to do negative v, you would turn it around, right? That would be negative v. If you wanted to do half of v, you would go halfway that distance right there, so that'd be like 1/2 v. So that's like multiplying it by a scalar. And let's say, if you want to do 2v, I'd have to make it a little bit longer. So it's supposed to cover three little spaces. So let's see, 1, 2, 3, 4, 5, 6. So that would have to, if I estimate a little bit, that would be like 2v. All right, so that would be like, basic things that you can do to a vector. You can turn it around, change its direction by putting a negative. You can multiply it by a scalar and things like that. So over here, you're going to basically just do these operations. So when you have this expression 2v plus w, and I've given you v and I've given you w here, so we want basically 2 multiplied by this negative 2 and 1, right? That's v, plus w, which is 3, 2. So basically you just do, add the parts. Like, so this piece is going to give you negative 4 and 2. I don't know why this keeps doing this. It's so annoying. And then you're going to be adding 3, 2. So you're just adding the x's and adding the y's. And so your final answer would be negative 1 and 4 if you add the parts. All right, so I guess I'll do this one down here. So w minus v. So take w, which is 3, 2. And then you are subtracting v, which is negative 2, 1. And so you just kind of subtract the parts, subtract the x's, subtract the y's. 3 minus negative 2 is 5, and 2 minus 1 is 1. Okay, so what you're doing right there, and I'll go ahead and just do one of them down below. So why don't we do the w minus v, or actually the 2v plus w, let's do. So 2v. So 2v was this vector right here. Remember, negative 4, 2. So 2v, so I have to start at the center, and it goes negative 4, 2. So negative 4 up 2 puts me right there. So there's that vector. That's 2v. And remember, when you do vector addition, you are like basically picking up where you left off. So we have 2v plus the 3, 2, which I guess was w. So from the end of 2v, I'm going to go right 3 and up 2. So 1, 2, 3, up 2. That puts me right here. So there it is. And so now you can see that the resultant, remember that when you add two vectors or do something with it, that's called the resultant. The resultant is the vector that goes from where you started to where you ended. All right, and so let me see if I can get that other one to go back to where it was. I cannot, so I'm going to have to just redo it. Okay, so we'll get rid of this. Of course, we love this. This is going to go here. And look at that. Notice that answer that we got earlier, negative 1, 4. Well, here it is, represented in this red vector. This red vector starts in the center and goes left 1 and up 4. So that is the vector and negative 1, 4. And so you can do it with a picture, but nobody wants to draw those pictures all the time. All right. So that result of you adding and subtracting and all that kind of stuff, that's called the resultant, and also called the displacement vector sometimes. All right, so unit vectors. So when you have a unit vector, you have a vector that is 1 unit long. Okay, so basically what's happening is, a vector can have a certain length to it. So let's call this, vector v. If I want a unit vector, and however long that is, like say that's like 5 inches, or well, it's a little bit bigger than that. Anyway, say it's like 7 inches long or something like that. And so if I want a unit vector, I want to maintain the direction, but I only want it to be 1 inch long. All right, so it's not going to be the exact same vector, but it's going to be a unit vector. And a unit vector, what it does is it maintains the same direction. So it maintains direction but makes the vector, or let's say makes the magnitude one unit. So to do this, if you had a vector v that you wanted to make it 1 unit long, you would take v and you would divide it by its own magnitude. And so this would be a unit vector in the direction of v. So let's go ahead and do that to this vector here. So first of all, if I'm going to do this, I need the magnitude of vector u. So magnitude, remember, is square root. I square all the parts, so 16 plus 1 plus 4. So what's that? 21. Square root of 21. Okay, so a unit vector in the same direction as u is going to be the vector 4, and I'm going to divide that part by radical 21. Then I'm going to take negative 1, divide that part by square root of square root of 21, and I'm going to take 2 and divide that part by the square root of 21. And that's my new vector. So the 4, negative 1, 2 is like maintaining the same direction that you were going, but the square root of 21 being divided is like shortening the length. And so if I were to do the magnitude of this vector right here, watch what would happen. I would do the square root. If I square all these parts, look, I get 16 over 21 plus 1 over 21 if I square each individual component, and then I get 4 over 21, which adds up to the square root of 21 over 21, which is 1, and so that's why it's 1 unit long. All right, so I got a couple more minutes here. I said I would stop at 10 minutes. Let's see what we can finish. So your standard unit vectors, you saw me use this earlier. I, J, K. So I is a unit vector because it means that you're going in the x direction 1 unit, and then nothing in the y and nothing in the z. J is for the y value, so it has no x, 1 for the y, and 0 for the k, or the z. All right, and k is 0, 0, 1. And so what those are, if you have like a little, oh my God, a little 3D graph, x, y, and z. So what this is this is just I, the vector I, is going 1 unit. Vector I is going 1 unit in the x direction. The vector j is going 1 unit in the y direction, and the vector k, is going 1 unit in the z direction. So it's just going 1 unit in each direction. All right, so let's take a look at this last part, and I think, all right, this is it. I'm going to finish this page, and we'll just be done that way. Okay, good. All right, so another way to write a unit vector, or a vector such as this in standard form, is to write w. And usually they have little arrows above them, or they're bold or something, like no big deal. Another way to write this is to write 3i plus 4j minus 6k. So that's called standard form. Okay, so you're going to see operations. So let's say I've given you u and v, and we want 2u minus 3v. So the long way to do it is to be like, oh, I want 2 times 4i minus 2j plus k. So that's 2u, because this was u. And then minus 3 times, oh, look, I have u twice, so this is going to be v. Minus 3v. So v is negative I plus 3j minus 2k. And, you know, it doesn't have to have all the letters all the time. Like if one of the parts is 0, then you, like if let's say it was, you know, negative I plus 3j on this last one right here, that means that this k would have a 0 in front of it. So it doesn't always have all 3 letters, but that just means the other part is 0. All right, so you can kind of think this in your head. We got 2 times 4i in the front, so that's 8i. And in the back, I'm going to have positive 3i, so 8i and 3i, 11i. Then for my j's, I got negative 4j in front and negative 9j in back. So negative 4, negative 9 is negative 13j. And then for the k's, I got 2k in front. It's going to be plus 6k in back. So 2 plus 6 is positive 8. So 8j. So again, this is that vector. And so if you were graphing it, you would have your x, y, and z axes. And graphing a vector, like in standard form like this, you start at the center and you basically go these directions in the x, y, and z directions. Okay? And I'll see you in class. Bye-bye.